In this activity, we will configure static and default routes using Packet Tracer. So here we have a topology, okay? And here we have addressing uh, uh, of all the networks. So okay, the first thing you need to do is when you're configuring a static route is to determine how many networks are there in total. Okay, so in this topology we have, let's see how many networks we have here. So we have one LAN here, which is 172.31.1.0, which is a network ID. Then the second network is 1.192, and it's a link between R1 and R2. Okay, if you remember, link between two router is one separate network. So 1 and 2. The third network is this LAN that is connected to R2, which is 31.0.0. Okay, so these are three networks. The fourth network is between R2 and R3, 1.96. And the fifth network is 31.1.128, which is LAN connected to R3. So we have total of 5 networks. So this is something you need to determine first when you're creating static routes. So we have total of 5 networks. Now we have to determine which networks are directly connected to each router. So let's start from R1. How many networks are directly connected to R1? 31.1.0 and 1.192. Okay, these are the two networks that are directly connected to R1. The reason we need to know this because when we configure static route in each router, we specify the network that are not directly connected to the router that you're configuring, right? So R1 is connected to these two networks. R2 is connected to 3 networks. This one, 31.0.0, 1.192, and the third one is 1.196. So these 3 networks are connected to R2. R3 is connected to 2 networks, 1.128 and 1.196. Okay. Now, how many static routes are required by each router to reach networks that are not directly connected? So let's see. So R1 is not directly connected to which network? So it's not directly connected to 31.0. Okay, it is not directly connected. If you look at here, it's the second network is not directly connected to R1 is this one, 31.1.96. So these are the two networks. And the third network that is not directly connected to R1 is this one, 31.1.28. So these 3 networks are not directly connected to R1. That means we have to tell R1 how to get to those networks by creating a static route on R1. Okay, so let's start. Uh, so we click on R1. All right, let's go to CLI. All right, to configure static route, you need to go to global configuration mode. All right, the command to create a static route is IP route. Now, since we're configuring R1, all you have to do is just look at the topology. Okay, R1. So which networks are not directly connected? One more time, are not connected to R1. 1, 2, and 3. Okay, and we have to create 3 static route one by one. Okay, the order is not important. Okay, it could be, you can start from either this one, or this one. So let's start from 172.31.0.0. Okay, so IP route, the network that we have to specify is 172 31.0.0 followed by the subnet mask. So the subnet mask is 24 bits, so that means it's 255.255.255.0. Now, so this is the network that R1 needs to know because it's not directly connected. Now, we also have to specify how to get to this network. Okay, so let's say if PC1 wants to access PC2, the packet will go to, well, where R1 this packet will send to reach to PC2. So R1 is connected to R2, right? So there are two ways to configure the gateway interface. Either you can specify your own the name of the interface of R1 or the next hop IP address. Okay, so R1 and R2 are connected. Let's see here how they're connected. So R1 is connected to R2 with on R1 is with serial 0 S000. 170 the IP address of S00 is 172.31.1.94, and on the other side on is connected to R2 with this IP address. Sorry, 172.31.1.93. Okay, so in this example we will configure the next hop IP address, which is also called recursive route. Recursive route is when you specifying the next hop IP address. All right, so the next hop IP address is 172 here 31.1.90 sorry, yeah, 31.1.193 172 31.1.93 172 31.1.193, and that's it. Now, so this is, so we configure the first network. There are two more. The second network is this one. Okay, 1.96. So, well, here you'll just change the IP address, I mean network ID, which is 31.1.196 1.196. Now, keep that in mind. Your gateway interface to get to that network is the same if you follow the packet. So if PC1 wants to access PC3, the packet will go to R1 and they will be sent to R2 because R2 is connected to R3, right? So the gateway will be the same. in this example. Now the third network is, so enter. Oh, sorry. 173. Sorry. The subnet mask is 252. That's the problem. It's not 255. The subnet mask of this network is 252. If you look at it here, is 26. Sorry, 30 bits. Okay, here is 252. Okay. Okay, what I'm doing wrong here. Sorry. So it's 255, 255, 255 dot 252. Okay, because here I write down 255.252.0. Okay, so that was a mistake here. So we corrected it, and it should good to go now. Now, third network. Well, we'll bring it here. The third network is this 172.31.1.128 with 26-bit with 26-bit subnet mask. So that would be 25. The subnet mask is B 255.255.255.192. Okay, again, the gateway will be the same. To reach to this network, R1 has to the packet has to go through R2, and R1 is directly connected to R2. So here what we are going to change here, only the subnet mask, which is here is 192. Sorry, the subnet mask is 192, 26-bit. So let's change the subnet mask 192. The last octet, we're not going to make that mistake again. And the network ID is 172.31.1.28. Okay, so here all we need to do is change 31 dot the last octet, which is 128. That's the network ID. Okay, 100. Enter. That's it. We're done with R1. Okay, so now PC1 should be able to ping or access PC2 and PC3. Okay, now if you want PC2 to access PC1 and PC3, we have to enable static routing in R2. So same thing. So R2 is connected to, it's not connected to, sorry, these only two networks, 31.1.0 and 1.1.28. All right, so we'll click on, let's access the R2 here. Enable config T, okay, and the command is IP route. Now let's start with this network first, 172, which is not connected to R2. So it's 172.31.1.0. Subnet mask is 25-bit. So which means is 128. Okay. Now you guys, if you want, if you guys want to know how to convert bits to decimal, you can use the calculator. All right. You don't have to do it manually. So here is 255, 255.255.255 128 subnet mask. Now, how do we get how PC2? So if PC2 wants to access PC1, the packet will go to R2, and from R2 it will go to R1. Okay, so the IP, the R1 is connected to R2 with serial ports. So this is a 192 network. So the IP address should be uh, the IP address of R1 here is 193. Okay. No, the IP address of R1 is 194. Okay. 194 because it's a 192 network, 30 bits subnet mask. So that means there are only two host IDs in this network. So 192 is the network ID, 193 and 194 is the host ID. Okay, 193 is assigned to R2 and 194 is assigned to R1. So we have to specify the next hop IP address. So in this case is 194. Okay, so let's see, 172 31.1.194, and that's it. Now the next network that is not directly connected to R2 is this one, 31.1.28. all right, so let's change the network ID first. 31.1.28, 31.1.128, and the subnet mask of this network is 192. 22 bits, 26-bit subnet mask is 192. Now, to get to this net, so PC2, if PC2 wants to access PC3, the packet will go to R3. Okay. Now, R3's the next hop IP address of the next hop IP address is the serial interface of R3. So let's see. We can just look at it. If this is 196, right? Or 30-bit subnet mask, that means only two usable host IDs. Okay, so 196 is, so 197 is assigned to R2, that means R3 is 198. Okay, so here we will change it to 198. And that's it. There are only two networks that are not connected to R2, and we only have to create two static route in R2. So we are done with R2. Now we go to R3. Okay, R3 is also not connected to three networks: 1.0, 1.92, and 31.1.0. These are the three networks. So we go to R3, click on CLI. We will go to global configuration mode. We'll go to global configuration mode here. And so first enable config T. The command is IP route. Now let's start with, again, the order is not important. You can start from here, with this network, or this one network. So I'm going to start with this network first. So 172.31.0.0. 172.31.1.0. 1.0. Okay, subnet mask 255.255.255 dot. Oh, sorry. Let's try it again. So IP route 172.31.1.0. Subnet mask is 255.25. So it's a 25-bit subnet mask. So that means it's 125-bit subnet mask is 192. Okay, where's the period? 192. Now, the next hop IP address. R3 is connected to R2. Okay, so what is the IP address of R2 is, it's 196 network, so it's 197. Okay, the next hop is 197. So 172.31.1.1, 172.31.1.197. Okay, this is the next hop IP address. All right, when you're configuring the next hop IP address, you don't have to specify subnet mask. All right, so enter. So we configure the first network. Now the second network is this 172.31.1.92. So what we have to do is, first we have to change 172.31.1.92. Okay, the network ID is 252. 255.255.255.252, because it's 30-bit subnet mask. So that's 252. And the next hop IP address will remain the same, okay, because it will go through R2. All right, so this is the second route, this is the third route. So it would be 192. 31.192, 31.1.1.0. Subnet mask is 25-bit, so the subnet mask would be 128. 128. And that's it. Now, so we have created the static route on all three router. Okay. Now, configure a default route on R3. How does a default route differ from a regular static route? Configure the default route on R3 so that every network not directly connected is reachable. So, all right. So when we were in R3, In so we configured these three route in R3. We are in R3, right? What we can do is, instead of configuring three routing entries, three static route, we can configure only one static route, okay, which is called the default route. So the command is IP root. A default route is a route that is not related to just one network. Default route is for any network, and it uses zero as a wildcard number. Okay, so for example, so in static route we specify the network ID, right? In default route, 0 4 zeros for octet. There are 4 zeros, right? For octet represent network, but it can be any network. This is not any specific network. It can be any network. Default routes are created on a router, usually on a router that is connected to the internet. A router need to know every network in order to route packet. Now, if you think about it, your router at home, which is connected to the internet, cannot know every single network on the internet, right? So how you're able to access the internet is because of the default route. On your router, on a router that is connected to the internet, there's one default route entry that points to the ISP router. Okay, so let's say if you want to access Cisco website, you type in uh, uh, for example, www.cisco.com. Your router does not know where this network is. Okay, so what it does is, when it receives the packet, it reads the destination address and it matches with its routing table. And if it does not find the entry, it send it to the next hop router, which is the router of your ISP. Okay, and then from one ISP, it goes to another ISP. Eventually, it reaches Cisco.com. Okay, so the IP root, 4 zeros means any network. Okay, followed by space, and then 4 zeros again. Specify 1 2 3 4. So 40 are network ID like this, and then followed by space, and the 40 represent subnet mask. Now R3 is connected to R2, right? So the next hop IP address is 172.31.1 dot, what is the R2 IP address here? Serial 197. So 198 is the address of R3 serial interface, and 197 is the R2 serial interface. Okay, 197. Okay, and this is how you create the default route. So instead of creating these three routes, we could create only one entry, And every time, so for example, if PC3 wants to access PC2, the router receives the packet, it matches with, and it could be any network, right? Since there's a default route, if it does not know, if it does not have the entry of that network in its routing table, it will send it to R2 instead of discarding the packet. Because whenever a router does not find the entry of a specific route, it discards the packet. But because of the default route, it will send it to R2. And then R2, you can also create a default route in R2, and then R2 will send it to R1. Okay, so this is how you create a static and default route in a router. Now, once you create the static and default route, always verify. The command, the best command to verify your static routing is show IP route. And you can see here, S means static route. So we have 1, 2, which we created, and 3 static route, right? And S with asterisk specify the default route. So here we have all 3 route plus the static route. And if you go to R2, let's do the same thing here. Enable show IP route, and you can see we have in R2 we have 2 static route here. Okay, C means directly connected network, L means link address of the interface. Okay, let's verify the third one, R1. Enable show IP route, and R2 also has 3 static route here, 1, 2, and 3. Okay, so this is how you create a static route on a network.